Hello all, and welcome to your next week in your new unit. We're going to start this week by talking about probability. And for some of you, this will be review. For some of you, this will be brand new. It's going to take place over 3 days. You'll notice that there are 3 problem sets from 9.2, 9.1, 9.2, and 9.4. So we're not doing 9.3, so pay attention to that. And they each have their own separate presentation and then odd numbered additional practice. But we're going to do one big video, and I still expect you to be doing a lot of the video is going to be today, and then working on these problem sets 25 to 30 minutes each day for the additional time. So find this page in your notes, and we're going to get started. So if you roll 2 die, so 2 dice like these that we see here, find the following. So the probability that their sum is above 10. So this is going to be really helpful for a lot of problems, is I've included this table in your notes. And the idea here is that we roll 2 die. This one has these results, the second has these, and it shows the sum of each of these here. So when it's asked when is the sum above 10, well, the sum here would be 1 and 1 of 2. Here the sum is 4 and 3, which is 7. So above 10, here's our line with 10. And remember, with probability, we are interested in what's the number of positive outcomes, the outcomes we want, out of the total possible outcomes. So if I look at this table, here there are 1, 2, 3, 4, 5, 6, all the way down. There are 36 possible outcomes here. And the ones that we want are where they're above 10. So that would be 5 and 6, 6 and 5, and 6 and 6. So you'll notice that I've circled 3 positive outcomes, the ones that we want. It is 3 out of 36. So we can leave it as a fraction, that's just fine, but we want to simplify it as 1 out of 12, dividing each of these by 3. Leaving as 1/12 is just fine, and the nice thing is you don't need a calculator for that. If you wanted to turn it into a percent, which some of you will, that would be 8 1/3%. Either of these is just fine. Now here, we have P parentheses doubles, and you might ask, what does that mean? This is just some notation. What this P stands for is probability. And then doubles is the idea of probability of rolling doubles, meaning that it is the same number for each. Now if I look here, doubles would be 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. So again, we're going to say there are 1, 2, 3, 4, 5, 6 outcomes that we're interested in, that we're like, oh yes, that's a success, out of the whole table, which is 36. Once again, we can leave it as a fraction, but we do need to simplify. Divide by 6, it's 1/6. Or if you want it as a percent, that would be, not 16, 16 and 2/3%. Either of these answers is just fine. Now, you might also have probability with a spinner. So looking at the spinner on the left, that's like this, like if you're playing a board game with your friends. Given the spinner on the left, find the following. So the probability of yellow. So probability of yellow, we've got 2 sections that are yellow, so that would be 2 out of 1, 2, 3, 4, 5, 6, 7, 8. So the probability of landing on yellow is 1 in 4, or again, as a percent, that's 25%. Now the probability of landing on yellow and even, if we look at this, there are numbers here, so 1, 2, 3, 4, 5, 6, 7, 8, but only one of the even numbers is on yellow. So we take away the 3, and the only success here is this pie slice of the spinner, this sector. So it's only 1 out of 8, which is already a lovely simplified problem, which you can also write as 12.5% if you prefer in percentage form. Now we're going to add in a little bit of vocabulary here, and this will go into the second 2 days. Theoretical probability is the probability that we've been calculating up till now. Probability of what you predict should happen. So what you expect to happen. So in an experiment of 200 test spins using this spinner here, how many would you expect to land on a prime number? Well, the prime numbers are the numbers that can't be factored. So I'm going to start by listing my prime numbers in this spinner, which are 2. 1 is not a prime number. It has only one factor. Prime numbers always have 2 factors. So 2 is a prime, 3, 5, and 7. And since it says the word expect, this means that we're just looking for the theoretical probability. So we have 1, 2, 3, 4 out of 8 would be our expected probability. So that's 1/2. And then it says of 200 tests. So we're looking for half of 200, which you can use division. It's 100 times. So we would expect it to land 100 times on a prime. Now, if I actually spun this 200 times, I wouldn't actually probably get 100. I might get 91. I might get 107. I might get 82. I would expect to get a number close to that if I actually did this experiment, but 100 just gives us a benchmark. Now, the actual thing that would happen in that experiment is called experimental probability. So this is the probability based on a test you actually did. You or someone. So it could be, someone in the textbook. It could be a classmate. It could be Mr. Belter. Someone did. So it's usually close to the theoretical probability, as I said, but it's not going to usually be equal. So in an experiment of 200 tests, the spinner landed on blue 85 times. What is the experimental probability of landing on blue? So in this case, we aren't even going to look at the spinner. We're going to ask ourselves how many times out of the total. So 85 out of 200 is the experimental probability. I can simplify this by 5, and I get 17 over 40, excuse me, not 20, 40, as this is our fully simplified fraction. This is 42.5% if you want it in percents. And you'll notice that if we were to compare it to the theoretical, blue is 3 out of 8, which is equal to 37.5%. And so what you'll notice here is, just as I said, experimental is what happened in the experiment. And these are different, but you'll notice they're close. 37 versus 42. Those are going to be reasonably similar, and I would say that this is probably a fair spinner in that case, since the experimental and theoretical probabilities are similar. If you have questions on any of these 3 lessons, please be in touch, set up a Zoom call, and make sure that you're nominating any homework questions in the forms attached.